Now, last week I put out a very devastating video to the flat Earth community on how did we actually obtain and verify the radius of the Earth. And in that video, what I did was I looked at some of the optical means that we have to address the radius of the Earth, specifically the Eratosthenes experiment, Al-Biruni, and then an equation I derived to answer a very specific question, to estimate the radius of the Earth based on how much of an object was hidden over the horizon. But that wasn't what I did the video for. It was just kind of the lead up to it. I addressed the optical issues, and then I presented my case for the fact that the distances across the ground, which are easily measurable by anyone, confirmed the radius of the Earth based on great circle distances. And that was what the entire video was about. But rather than address that, Quantum Eraser wanted to seize upon the formula that I came up with, which we kind of tongue-in-cheek named the method Al-Biruni. But let's go ahead and have a look at that presentation so that we can get some clues and some insight into his misunderstanding of the problem, his misapplication of the mathematics, and the faulty conclusions that he reached. So let's go ahead and have a listen to Quantum Eraser.
All right, so we're back to Bob, the Al-Biruni pseudoscience fallacy, flathead, Herman Munster, quanumrum, retard of the century guy.
Now seriously, John, what are you, about 8 years old? You know, if you want to be taken seriously by adults, you have to present yourself as an adult, and that's not how you do it, my friend. Why don't we go ahead and get on with your claim, and then we'll show you where you went wrong, and maybe you'll learn something from it.
Well, this is the Pythagorean formula, for goodness sakes. And I'm sitting there, okay, what is he doing with this? Oh my God, dude. This is Pythagorean. But you didn't come up with this, Bob. And then you and Hillbilly Blue Balls, the redneck retard, he helped you coin Vinnie Barbarino?
All right, so let's go see if we can help John out a little bit. First of all, that's not the Pythagorean theorem. That's the Pythagorean theorem. As you can tell, they're not the same. Now, what I did with my math was that I took the curve calculator, which is the one that you see online. Walter Bislin's is a good example. And what I wanted to do is I wanted to see whether or not I could determine the radius of the Earth based on the amount of an object in the distance over the horizon that was hidden from my view. Now, just to save you the trouble of going through it again, I'll go ahead and link the video where I came up with this, so that you can review it in its entirety. It's a 10 or 15 minute video, and I don't want to have to go through it all again right now. But here's what I came up with. If I was standing on the shore, right here, there's me, and I looked out at the horizon, there would be a point that would be my horizon. Now, if I am 6 feet tall, or 6 feet above the water, that point would be 3 miles away, roughly. Now, the thought that I had was it would be very difficult for me to stand here and try and figure out where that was. However, if I was here with just my eyes above the water, I could not see anything on the shore below my height, because right there, all that would be hidden from me. And what I did was I went ahead and I used this example after deriving this formula from the curve calculator. And that is that the distance between me at the surface of the Earth and the object I was looking at, and the height is what height that object has to be before I can see it. So in this case, I can't see any of this. It has to be at least 6 feet off the ground, or 6 feet above the water, for me to see it. And that is my H.
All right, let me finish it up.
Now, what I did with that was I looked at the distance to an object.
You looked at the distance to an object. What object might that be, Bob? I mean, just any arbitrary object? We can just look at the object?
Now, do you see the tactic that he's using right now? He's trying to restate my premise. What is this formula for? It is to determine the radius of the Earth based on how much of a distant object is hidden by the horizon. So in other words, if you're out at this point right here, you can't see any of this structure in the distance. It's hidden from you. It has to be at a certain elevation based on the distance to it before you can see it, because the rest is hidden by the curve of the Earth. The way this formula works is you have to have a distant object that is partially hidden by the horizon. That seems to me to be common sense and wouldn't need to be explained to somebody. But have a listen to Questionable Education and his take on that.
I mean, just any arbitrary object? We can just look at the object? That's how you did it?
And the height of the object that was hidden from.
The height of the object that was hidden. Now think about that. The height of the object that was hidden. That's non sequitur. I mean, you're not going to be able to do anything with that. The height of the object that was hidden. What does that even mean? I don't know.
From my view. And what I found was that if you took the distance and squared it.
The distance to what? To the fairy tale object here. Unbelievable.
Subtracted the hidden height squared.
You subtracted the hidden height squared. Like I said, it doesn't make any sense so far. What you're putting with these variables is nonsensical buffoonery. We're going to see it a little bit closer here. I just wanted to let you guys hear this nonsense so you didn't think I was making it up.
And divided it by 2 times the hidden height. You came up with the radius of the Earth. Now,
Yeah, sure we did, Bob.
well, since John can't seem to figure this out and never bothered checking it, let's go ahead and go through it together. Now, if an object has to be at least 6 feet off the water to be seen 3 miles away, that's how far it is to our horizon. But if we're in the water at 3 miles with just our eyes above it, something has to be at least 6 feet high before we can see it. So our numbers are, we've got 3 miles, that's the number of feet in 3 miles. And we have the hidden height of 6 feet. We square that, subtract the square of that from it, divide it by 2 times the height, and we come up with 20,908,797 feet. It's a simple matter to divide that by 5,280 feet, and we come up with a radius of the Earth of 3959.99. It works just fine. Now, one thing that I did address in the video is that this is not the true geometric radius of the Earth. What this is the refracted radius of the Earth. Now, for those of you that are not familiar with refraction, light bends in our atmosphere and makes objects appear to be higher than they are. That is the exact same effect of having an Earth with a larger radius than the actual geometric radius of the Earth. That's why we sometimes refer to it as refraction equals 7/6r. And as a result, we see a little further than we would expect to see based on just the geometric size of the Earth. You know, you do have times of extreme refraction. The black swan photo is an excellent example of that. That is an example of extreme refraction near the surface of the Earth. And that's why they're pointing that out, and that's why I went to the distance across the ground as a proof of the radius of the Earth. You can't refract a measured distance across the ground. But rather than address that, they wanted to make fun of the fact that Blue Marble and I came up with the idea of calling this the method Al-Bob-Rooney as a play on the method Al-Biruni. Apparently, John didn't think that was very funny. Well, oh well. Guess what, John? My sense of well-being does not depend on your approval, nor does the accuracy of my mathematics. But let's have a look at the accuracy of your mathematics and your understanding of this problem.
Bob the delusional flathead Herman Munster bonehead says that he came up with his own method for deriving the radius of the Earth. And with the help of Hillbilly Blue Balls, the redneck retard, the photosynthetic redneck, coined it Al-Bob-Rooney. He changed what the variables meant. We'll see that here in a few seconds. This mytho-mathematical Mr. Magoo Muppet Moron Belly Laugher will give you the radius of the Earth, according to Bub. So, distance to what? Like I said, Bub. What's the object? Can it be a toothpick at 25 paces? Will that give me the radius of the Earth?
You know, I thought that you had to hear that to believe it. A toothpick at 25 paces. This is a method for finding the radius of the Earth, or at least an estimate of the radius of the Earth, based on how much of a distant object is hidden from your view from the surface of the Earth. Now, we use the example of me being out here, and things had to be 6 feet high before I could see them at a distance of 3 miles. How much of the toothpick is hidden at 25 paces? Assuming, of course, it's out in the open. You know, we're not going to play their little game. Well, what if there was a big steaming pile of fertilizer in front of the toothpick? It would be blocked from my view, so therefore I could use it to calculate the radius. No, that's not what this method's about. It's objects that are past the horizon. How high do they have to be before you can see them, assuming that your point of observation is at the surface of the Earth? You know, flat earthers love to try and take advantage of the effects of refraction, which they know very well. That's why they always put their cameras way down by the water. This was a great way not only to estimate the radius of the Earth, but how much refraction was present by comparing that radius to the known radius of the Earth. But you see how he's trying to strawman me by rephrasing my argument. Now he wants to use a toothpick at 25 paces. That's not what this is for. That won't give you the radius of the Earth any more than putting pepper on it will. It's simply an inappropriate use of the formula, and he knows it. But he's trying to mislead his audience into making them think that he's smart and he found a flaw in it. That's not what it was designed to do in the first place, and he damn well knows it. And anybody over the age of about 8 would be able to figure that out. But let's continue.
The height of the hidden toothpick? Unfriggin' believable. Like I said, height of the object hidden is non sequitur. Even if he spun it around the right way, no doubt it's going to be in feet and inches with Muppet vision. And why is it hidden? Isn't that important? Where's that variable in the formula? Beyond belief, booger-eating buffoonery, folks. That's what this is. We're off the edge of the map. Here, folks. So, let's take a peep at what the variables in the formula actually mean and how the formula is actually used to determine the radius of the Earth.
Okay, now before we go into the black swan, let's go ahead and correct some misconceptions that people have about the black swan. First of all, the globe distance to the black swan from the observer point as listed, although I don't think they actually put the coordinates in, is 9.41 miles. Let's assume that that's correct because it does seem reasonable. You multiply that out, you get 49,685 feet. You square that, and then you have to subtract the square of the hidden height. This is a flaw in the argument for the black swan. Brandon Toy and I actually looked at that, and you cannot identify anything below about 20 feet above the waterline on the black swan. I've got a full video on that. They never take that into account, the fact that part of the black swan is hidden by the curve of the Earth, because the horizon is between the beach and the oil rig. It's actually at about 1.85 miles. You divide that by 20 times 2, and you get a radius of the Earth of 11,688 miles. Why so big? Because it's an extremely refracted day. Extremely refracted day. That's why we don't do measurements like this on days with that type of extreme refraction. Now, if you look at a regular photo of habitat, you're going to find probably 40 feet of that oil rig is missing over a nice clear horizon, not an ambiguous one like in the black swan, but over a nice sharp clear horizon. Do the math for that, you get something that's a lot closer to the actual radius of the Earth, because that's a normal refraction day. Now, one last thing that I really want to emphasize. That's a great circle distance on a sphere. If you want to claim the Earth is flat, you can't use the great circle distance. I'm not going to allow you to do that. you have to calculate the flat Earth distance based on triangles. You can't use a globe distance to claim the Earth isn't a globe. That is a true non sequitur. The globe distance is a great circle distance across the surface of a sphere. You find it using spherical trigonometry, specifically something called the Haversine formula, and that's right here. Now on the flat Earth, you must use a two-dimensional triangle, and you can only use the Pythagorean theorem or the law of cosines. So let me show you how to calculate the flat Earth distance between 2 points. So if you have point 1 here, and you have point 2 over here, what you have to do is you have to draw a line to the North Pole and then back down to point 2. This angle is the difference in longitude between these 2 points. The length of these lines is based on the number of degrees of latitude between your position and the North Pole. So for example, if that's at 40 degrees north latitude, it will be 50 degrees to the pole, or 3,000 miles. Here, we'll bring this down a little bit, but likewise, if this one is at 30 degrees north latitude, it is 60 degrees to the pole, or 3,600 miles. Now, what you need to do then is you need to figure out that distance. You solve for the triangle. Now, if this is 90 degrees, you can use the Pythagorean theorem. If it's not, you have to use something called the law of cosines. You have that angle, and you have these two sides. You have to solve for that one. And the formula for that is rather simple. If that's A, that's B, and that's C, C squared equals A squared plus B squared minus 2AB cosine your angle. Have at it, folks.
So, let's take a peep at what the variables in the formula actually mean and how the formula is actually used to determine the radius of the Earth. We'll use everyone's favorite, the black swan. Now, just in case this is a little bit, it's kind of small. Let me see if I can help you out here. Ha ha! How about that? So, if everyone could look right here beneath Pythagorean formula right here, does everyone notice what this looks like? What is this? That's Bob's formula, isn't it? There, right there. That's Bob's formula. He just stole it from Pythagoras. He made it his own, right? And he called it Al Barbaruni. There it is, folks, right there. So it's easy to find the radius, right? Using Pythagorean formula. We did it back in 2020 when the Black Swan first came out, right? The radius in miles equals the distance to the horizon in miles. Viewing height, right? That's what H means. And over 2 times the viewing height. That's all this is, folks. Right? If you plug all the numbers into the formula with the Black Swan at 1 foot observer height and distance to the horizon is 10 miles.
Okay, so did you see how he tried to do the switcheroony on you? Now, granted, that is a similar form. However, it was derived differently and measures different things. For example, this assumes that you are at the horizon with an observer height of 0. The H is not your observer height. The H is how high an object has to be before you can see it at distance d. So that's a very different way of looking at it. And that's what this entire formula is based on. It's a different way of looking at things. It's designed specifically for observations that are very close to the ground, looking out at distant objects that have a portion of them hidden by the horizon. Second of all, there is no distance to the horizon. You are at the horizon for that object. You have a distance to the object, but there is at no time the distance to the horizon needed. Now, in the black swan calculation, how did he measure the horizon being at 10 miles? How do you have part of the black swan oil rig below the level of the horizon if the horizon is after it? They didn't look into the black swan at all because they were trying to force a narrative. They never actually examined the black swan and saw that the entire boat deck was below the horizon. All you can see at most is part of the upper railing of the boat deck. That boat deck is over 15 feet off the water. So the idea that the horizon is somehow 10 miles past the oil rig is made up of whole cloth to support the narrative. Now, with heavy refraction, such as you see with the black swan, you can get the horizon seem to curl up due to the extreme refraction. The black swan is in front of that. There is horizon in front of the black swan, which is why you have the bottom 15 or 20 feet missing from the oil rig. They never thought about that. They never took that into account. They claim that the entire oil rig is visible. It is clearly not. And I have a full video with Brandon Toy about that, demonstrating that conclusively. That's why I put 20 feet hidden height in here, because 20 feet is hidden. But because QE put garbage numbers in this and used it in a different way, he came up with a garbage answer. Let's go ahead and listen to it.
If you plug all the numbers into the formula with the black swan at 1 foot observer height and distance to the horizon is 10 miles, guess what you get for the radius of the Earth? Guess what that might be? Right there, baby. 264,000 miles.
You know, I think it's important to note that that's more than the radar measured distance from the Earth to the Moon. So here's the bottom line, QE. When you try and do middle school math and you come up with a weird answer like this that makes no sense, you did something wrong. Can you think back to where you made your mistake? Your mistake was putting whatever number you wanted to into the distance to the horizon. Had you applied the formula correctly, as I've demonstrated here, you still get a very large radius because of the severe refraction and the fact that the observation was not truly at ground level, it was a foot above ground level, which skews it a little bit as well. But that gives you a really good idea of what you're dealing with. That is nowhere near greater than the distance from the Earth to the Moon. It's nowhere near what you think that it would have to be. And it accounts for what we actually see on the spherical Earth. And by the way, QE, speaking of spherical Earths, it doesn't matter if the Earth has a radius of 3959, or just under 12,000, or 264,000 miles. It still has a radius. It's still a sphere. The only difference between those numbers is how big that sphere is. At no time does that indicate that the Earth is flat. Well, that was our look at the math skills of one questionable education and his conspiratorial narrative. Hopefully this cleared up a few things. We'll have little talks like this from time to time where I'll address things that are going around in the conspiracy community. Try and make some sense out of what they're claiming and then show you the correct way to do it. This is Bob the Science Guy signing out from Northern Michigan. Thank you again. Make sure you hit that like and subscribe and stay healthy, folks. Till next time, take care.